Okay, today's lesson is going to be over section 5.2. In section 5.1, we learned how to take the derivative of a natural log problem. So today we are going to integrate the integral of 1 over x or 1 over u du. So I'm going to start by giving you a couple of formulas and then show you some example of some worked out problems. The integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. And we know this works because the derivative of natural log of x is u prime, or your dx, over x. The absolute value is there because you cannot take the natural log of a negative number. So if it's the integral of 1 over u du, that will equal the natural log of the absolute value of u plus c. Now let's do a couple of example problems. The integral of 1 over 4x plus 1 dx. U will equal 4x plus 1. The derivative of that is 4 dx. We want it to be 1 dx, so we divide by the 4. And this will be 1/4 the integral of 1 over u du. Your formula for the integral of 1 over u du is the natural log of the absolute value of u. Now, because the coefficient is 1/4 and your logarithmic properties, you might see this written as 4x plus 1 raised to the 1/4 power plus c. I like keeping it as the coefficient of your natural log. Okay, another example. The integral of 3x squared plus 1 over x cubed plus x dx. Now, you know that the denominator is going to be your u because it is raised to the power of 3. The derivative of that will give you an equation with the degree or power of 2. So you always want the derivative to fit in with what's left over in the problem. So u equals x cubed plus x. Du equals 3x squared plus 1 dx. That's exactly what we want it to be. So this will be the integral of 1 over u du, which we know is the natural log of the absolute value of u plus c. There are 4 trig derivatives that fit into this category. The first one we're going to talk about is the integral of tangent u du. If we write this integral as the integral of sine u over cosine u du, we will pick the denominator to be our u as our integral substitution. So u equals cosine u. The derivative of that is u prime cosine u du, which is, sine u, which is what we have in the numerator. And the derivative of our cosine u will also be negative. So we will divide by 1 over u prime, whatever our coefficient will be. Du equals sine u du. Now we make a substitution. So this is the integral of du. I'll put the coefficient out front. And this will be 1 over the integral of u du, which is my coefficient, natural log of the absolute value of cosine u plus c. So that is the proof. What I want you to remember is that the integral of tangent u, and you can go through the proof and work it out every time if you want, or you can remember that the integral of tangent u du will be negative natural log of the absolute value of cosine u plus c. The integral of cotangent u du is natural log of the absolute value of sine u plus c. The integral of secant u du equals natural log of the absolute value of secant u plus tangent u plus c, and the integral of cosecant u du equals negative natural log of the absolute value of cosecant u plus cotangent u plus c. So let's do an example of one of these trig integrals. You want to make sure that the integral is in this exact form before you use the formula. So let's just do the integral of tangent 4x dx. U equals 4x. The derivative equals 4 dx. So 1/4 du equals dx. So 1/4 the integral of tangent u du is equal to 1/4, and then we use our formula. It's negative natural log of the absolute value of cosine u plus c. The other three formulas work exactly the same way. Again, they have to be in that form. If they're not in the form, like if your trig integral looks like this, integral of secant squared u, here let's make that 2x, over tangent 2x dx. You need to look at the problem to see which trig function has a derivative of what's left in the problem. So in this case, u is going to be tangent 2x. The derivative of that is 2 secant squared 2x dx. So I divide by the 2. I then substitute 1/2 the integral of 1 over u du. So again, I am not integrating a trig function, I'm integrating 1 over u. So 1/2 natural log of the absolute value of tan 2x plus c. I would like you to try a couple problems before you come to class tomorrow. So, on page 338, I would like for you to do numbers 6 and 7. I would also like you to try one of the trig integrals. So why don't we try number 30 and 33. Good luck, and I'll see you in class tomorrow.